If you walk 2 kilometers north, 3 kilometers at 30 degrees south of east, okay, and 2 kilometers east, how far are you from where you started? Okay, let's draw a picture. Love my pictures. Okay, here's my x direction, here's my y direction. Let's start this thing off. So we got 2 kilometers north, okay, so there. Okay, we'll call that v1 vector. And then we have 3 kilometers at 30 degrees south of east. Okay, well, which way is east? East is, so I'll start here. So east is this way, and it says south of east. Okay, so south of east is this way. So it must go this way. How far? Oh, 30 degrees. Oh, that makes sense. Okay, 30 degrees south of east. So right there, oh, how far am I going? 3 kilometers, so about that much. And this angle here is 30 degrees. Okay, and we'll call this V2 vector. And then 30 degrees, so 3 kilometers at 30 degrees south of east, yes, and 2 kilometers east. Okay, so another little east there section. Okay, and that's called V3 vector. And what it's asking me, how far from where you started? Okay, so how far am I from where I started? So this location right there. And I'm going to call that V final vector. Okay, and I know that the addition of v1 vector plus v2 vector plus v3 vector is equal to v final vector. Okay, so let's do this. So v1 vector is equal to, okay, v1 is going to be all in the y direction, so 0 in the x hat direction, plus in the y hat is going to be 2 y hat. Okay, v2 vector is equal to, oh, I can only accept x's and y's here, because that's how I'm breaking this thing down. And, okay, so I got to use some trigonometry here. So I'm going to take this vector, and this is the good rule. Whenever you get a vector that's not in line with the coordinate system, you can extract it, put it over here, make a little triangle. I'm making this triangle up. I know that this one, it said 30 degrees, because it's 30 degrees south of east. And I know the distance was 3 kilometers. And what I really want is I want to have my x and y location. Okay, I want those distances because I can take those distances, the x and y components of this vector, and put it into this equation. So let's extract the x and y components. Okay, so this is going to be, I know that sine, yeah, let's do sine of 30 is equal to opposite, which is y, over hypotenuse 3. So y is equal to 3 sine 30. Okay, and that's equal to sine 30 times 3 is 1.5. Okay, and similarly, x is equal to 3 cosine 30. Okay, because x is going to be the adjacent one, whereas sine is going to be associated with the y. So this is going to be 3. It's not always the case. It's just that sine is opposite. In this case, it would be y. So sine opposite of this angle is the y. Does not mean that sine is always associated with y. 3 times cosine of 30 is equal to 2.6. Okay, so now I have my components. Now, one thing to remember here is that this gives you the value. Because these angles are always between 0 and 90 degrees, they're called relative angles. And these values will always be positive. Whereas in the grand scheme of things, x is positive, but y is actually going down, right? Because I started here and my vector went here. So I went this way, which was positive, but I went this way down. So my y is actually negative. It's negative 1.5. And you would get that answer if you took your angle from here, which would be 360 minus 30, 330 degrees. If you took 330 degrees and took the cosine, you could get that. It's called an absolute angle. I think that's more confusing. I like to put the negative in myself. So watch this, how I translate this information into here. So in the x direction, it was 2.6 x hat. And in the y direction, well, now I went down. So it's actually minus 1.5 y hat. I think that's a lot more, it's a lot easier just to have all these positive values here, and I manually put in negative or positive with respect to my picture. And I always deal with a relative angle between 0 and 90 degrees. Let's finish this thing off. So v3 vector is going to be, well, this one's already aligned with my coordinate system, so I don't need to do this. 2 kilometers east, so it's going to be 2 x hat plus 0 y hat. Add all these things up, I'm going to get v final vector, and it's going to be equal to 4.6 x hat plus 0.5 y hat. And the magnitude of that vector, v final x squared plus v final y squared, actually, there it is, plus the 2 gives me 4.9, is more accurate. Square that answer, plus the 0.5 squared, square root answer is going to be 4.63, and kilometers. We are in kilometers.